Electrical energy. It's awesome, isn't it? That flash of light, that sudden release of electrons, produced millions of volts of uncontrolled electrical energy, enough to light New York City. By comparison, a familiar spark such as this can create as much as 35,000 volts, enough power to give you a slight shock, or damage a circuit pack such as this. When electrons are at rest on a surface such as your body, that form of energy is called static electricity. However, when electrons are suddenly and uncontrollably released from one surface to another, it's called electrostatic discharge, or ESD. ESD has the potential of releasing many thousands of volts. Only recently have we recognized this uncontrolled phenomenon as a powerful force. It can create serious problems and is costing industry millions of dollars annually. In this age of electronics, your sensitive and sophisticated equipment has a very low tolerance for electrostatic discharge, or ESD. Devices like MOSFET, bipolar transistors, film resistors, and VMOS, and many others can be damaged by small amounts of voltage, in fact as little as 100 to 300 volts. Since most of these devices operate on as little as 1 to 5 volts, and ESD generates 30 volts and more, that difference is just too much for these devices to tolerate. Let me give you some examples of how ESD affects industry. A rocket was being tested in a hangar at Cape Kennedy. The tests were being performed with a polyethylene dust cover over the rocket. The rocket had its ignition device in place and was grounded. While performing final testing, a technician had to remove the dust cover. When it was removed, the separation generated approximately 37,000 volts, which leaped to the grounded ignition device. That spark, no greater than one you might cause by walking across a carpet and touching a door handle, created a deadly explosion of the rocket fuel, which killed 4 people and hospitalized 11. In the early 1960s, NASA was having a large number of missile launch failures. About 70% of these failures were caused by sudden release of electrons jumping from one surface to another. And the culprit? Dust particles that were electrically charged. Recognizing this, NASA scientists developed a way to eliminate most of the dust by constructing what is known as a clean room. These rooms, under ideal conditions, have no dust particles larger than 1/10 the diameter of a human hair. Although the scientists removed most of the dust, the electrons at rest remained a problem. Situations like those caused scientists to look for a way of controlling this uncontrolled pulse of energy. By looking at ESD more closely, they discovered 5 characteristics of electrostatic discharge. It creates locally intense heat, locally intense light, and sound. That's the pop or snap you hear. ESD also broadcasts an electromagnetic field, and that's the static on the radio or record player. By now, you may be asking, what does all this mean to you and your business? Simply put, AT&T is losing millions of dollars annually because of electrostatic discharge. The electronic systems you work on use low-voltage circuit packs, which can be seriously damaged by ESD. Find the cause and eliminate it, and you have no problems. But that's not so easy. I'm sure you've seen how fur and hair generate ESD. But nylon, plastics, cotton, and even paper can generate more than enough to damage these circuit packs. All synthetic materials have the potential of generating large amounts of static electricity. This simply means that your electronic systems are in danger of being damaged every time circuit packs are handled. To show you what I mean, I'm going to conduct a few demonstrations using this static meter. It measures ESD in increments of thousands of volts. I'll just take a short stroll across this vinyl floor. How many volts do you think I can generate? About 12,000 volts. That's enough static to give me a slight shock, and it's much more than any circuit pack could handle. Now I'll walk across the carpet. How many volts do you think a walk on a carpet can generate? It's about 35,000. This is something most of you work with. It's a solder sucker. It generates about 4,000 volts, and it's just common plastic. There's one other interesting fact about ESD. It can be affected by the amount of humidity in the air. When the humidity is increased, the amount of voltage generated is decreased. The humidity here is about 10%. So if the humidity were increased to, say, 50%, walk across the vinyl floor would only generate about 3,000 volts, and across the carpet, about 7,500 volts. That's a big difference. However, still enough to destroy a circuit pack. This roll of tape, when separated, generates about 2,000 volts. Separating this plastic lunch bag generates a high enough voltage to do this. Although that's not enough voltage to run the lights in your home, it's more than enough to create serious problems in electronic systems. Here's a little demonstration I've made up for you. I'll need some help for this one. Watch what happens when my assistant touches the board. Thank you. That flash was an electrostatic discharge. This is an area of a circuit pack enlarged 4,300 times to show the damage ESD can cause. These are actual examples of damaged circuit packs. Before we go any further, let me make this point. All that I've said and all that you've seen so far has been for one purpose, to let you know that ESD is a major problem. And let me say it again, ESD is a major problem. Along with all of this, AT&T and Western Electric are taking measures to ensure that ESD will be eliminated in the manufacture, installation, and repair process. Here at Western Electric's Denver plant, the assembly line has been revamped. This is to ensure that you have the best possible product in your hands when you start working on electronic systems. Every precaution has been taken to neutralize ESD before you receive a circuit pack. This is one of the new assembly lines. It's grounded, and all the materials used on this line are conductive. From the first printed wire board to the shipping of a circuit pack, everyone is grounded. For example, this employee is standing on a grounded conductive floor mat. Notice the shoe strap to ground his body to the mat. As we follow the circuit board down the assembly line, a conductive shunt is placed on the gold fingers. As more components are added, they are taken from new conductive bins and shelves. Further down the assembly line, more components are added. And every employee has a wrist strap, or they are grounded by standing on a conductive floor mat. At this position, the boards are checked and missing components added. They move into the solder machine where the flux is added. Then the solder flow. From there, the boards move to a cleaning system where the flux is removed. Both the solder and cleaning systems are anti-static. This employee adds face plates, and the other employees add 4 transformers to each circuit board. Each bench has an anti-static Formica top. More components are added. The solder is touched up, and the gold fingers are cleaned. The circuit pack is tested. After testing, the gold fingers are cleaned again. Then they are placed in an anti-static pink bag, then into a packing box for shipment. When you receive the circuit pack from Western Electric, it will look like this. And that brings us back to you. As always, you make the difference. It's up to you to ensure that the static charges between you and the equipment are neutralized. How? With the wrist strap. There's several here. Never handle the circuit pack without wearing one of these wrist straps. This is a sure way of neutralizing ESD. Ron is about to start working on this system. We'll watch to see how he neutralizes ESD. He attaches the wrist strap to the body of the system. The other end he attaches to his wrist. Make sure the strap is on your skin, not on your clothing. He is now grounded and in control. By grounding himself, he has just neutralized all the static stored on his body, and he's ready to work on the system. Also, in some systems, you may have to attach to a designated grounding point. Make sure you do. Notice how Ron holds the circuit pack by the outside edges. Never touch the components or the gold fingers. Damage is most likely to occur at this point. See how carefully he handles the circuit pack. He doesn't force the pack into the carrying case. Ron is certain that the circuit pack is aligned in the grooves of the carrying case and system before he gently slides them in. This is another point where extraordinary care should be taken. Never force the circuit packs into the grooves. You may bend or break a component. Take time to line up the circuit pack and grooves. The wrist strap and how you handle circuit packs are the keys to neutralizing the effects of electrostatic discharge. You should check the wrist strap to make sure it hasn't been destroyed. If there's no path to ground, then ESD is back in control. Test it once a month. How do you test it? Make a continuity test with a volt-ohm multimeter like this. Make sure it's calibrated. One end here, the other here. That's it. Once you're grounded by the wrist strap, you can work on any system. You can safely remove circuit packs from their packing material or from your carrying case. You can remove or replace circuit packs in electronic systems. You can troubleshoot with a logic probe or perform microdiagnostic tests and work on any tape drive system. The wrist strap will not inhibit your movement, and it will allow you to do your job safely without harm to the equipment by neutralizing ESD. Let's summarize the steps. Handle all circuit packs with care. Don't mark or place tape on the ones you've removed. Remember the amount of ESD generated when I peeled the tape off. Place each pack in its pink bag so it can be shipped safely. This leads to two things: savings to the company and customer satisfaction. While we're on savings, AT&T has established screening and turnaround locations for circuit packs. The first location is in Chicago. It works this way. Circuit packs are shipped from the field to this location. The gold fingers are clean. And then the packs are tested under operating temperatures. If the pack tests okay, it's shipped back to the field. All others are shipped back to Western. Every pack that's okay saves money. Well, everything you've seen so far is aimed at protecting the sensitive equipment you work with. Let me review what we've covered. ESD is a serious problem. AT&T and Western Electric developed new manufacturing and shipping procedures. And last is the wrist strap. This is where you can make the difference. Just remember to use the wrist strap before you work on any electronic system. By following all of the procedures you have just seen, you will neutralize ESD. If you do this, millions of dollars will be saved because of you. Procedures are being universally applied. That means all points: manufacturing, shipping, receiving, installation, repair, and testing. The old ways of doing things simply will not work. The space age is here, and through it we have crossed the threshold of microcircuitry into the expanding universe of future communication. The question is no longer, what will this age be? But rather, what will each of us contribute to it?
Everything looks real good. Crew